Okay, so here I'm going to have a look at the Leaving Certificate Higher Level Maths Paper 1 for 2017. And I'm just going to have a look at question 1 in this video. So the first part of this question was to do with this quadratic function here, f of x is equal to 2x squared minus 7x minus 10. And what we've got to do is write this in this format here, completed square format in other words. A times x plus h to be squared plus k. And a, h and k here are rational numbers or elements of Q. So let's just write this down then and start the procedure. So we have f of x is equal to 2x squared minus 7x minus 10. So you've got to write this in completed square form. So first thing I want to do is make sure that the coefficient of x squared is 1. So let's just take the 2 outside the bracket here. So I'm going to just divide across by 2, so that'll give me 7 over 2x here and 5 here. So I've just factorized out the 2 here. Now I can just leave the 2 where it is until the very end. I'm not going to do any more with this 2 till the very last step really. And what I'm going to work on is this quadratic trinomial expression here within the bracket. So let's start on that one. So the procedure here is just simply to take the coefficient of the x, which is 7 over 2. So I'm going to take 7 over 2. I'm going to half it. So that will give me 7 over 4. I'm then going to square it. So that will give me 49 over 16. So I've halved the coefficient of the x, squared it. What I'm going to do next is add it and subtract it to this part here. So I'm going to take x squared minus 7 over 2x. I'm going to add 49 over 16. I'm going to subtract 49 over 16. And then I have this minus 5 out here at the end as well. So all I've done really is taken this quadratic trinomial expression here within the brackets. All I've done is, I haven't changed it really, I've just added and excuse me, I've added and subtracted 49 over 16. Okay, so that allows me then to just take this quadratic here, this quadratic trinomial part here, and factorize these three terms here. When you do that, what you get is x. Now it's going to be something like this. X times x will give me this x squared here. Now what I'm going to end up with in here is actually 7 over 4. So I'm going to end up with minus 7 over 4 minus 7 over 4 here. Now you'll find that if you multiply x by x, you'll get this x squared here. If you multiply minus by minus, you'll get this plus here. 7 over 4 times 7 over 4 will give me 49 over 16. And then the two bits in the middle here, minus 7 over 4x minus 7 over 4x will give me minus 14 over 4, which is just minus 7 over 2, and this is a minus 7 over 2x here. So when I multiply these out, I'll get these three terms here. Now what about these two here? I haven't done anything with these yet. If I add those two together, what I'll actually get is minus 129 over 16. You can do that on your calculator. This is what you'll end up with here. So let me just move this up a little bit here. So what I've ended up with here is this 2. This here is just x minus 7 over 4, which I'm going to square. And then I've got minus 129 over 16 here. Okay, so we're almost there. So last step then is just to multiply out the 2 here. So I'll end up with 2 times x minus 7 over 4 squared, and out here then I'll just end up with this 129 over 8 when I multiply by 2. And that's really it. This is the a times x plus h to be squared plus k. So my a here is 2, the h here is minus 7 over 4, and the k part here is minus 129 over 8. And they're all elements of Q, they're all rational numbers, these three here anyway. Okay, so that's the first part. Let's have a look at the next part then. Next part just says, hence write down the minimum point of f. Well, from the completed square form, we can look at these two values here, which will give us the turning point, or the minimum or maximum point depending on your quadratic. In this case, our quadratic will look something like this, and there'll be a minimum point down here, and this is given by these two numbers here. So our minimum point is just going to be, so our minimum point of f is just going to be, this is going to give me my x value, but we need to change the sign here, so it's just going to be 7 over 4, and this is going to be my y value, that's going to be minus 129 over 8. Now I've actually drawn this, I'll put that up for you. It looks like this here. So you can see that our minimum value here is down here. And you can see from what we said back here, it's going to be 7 over 4 on the x-axis. So 7 over 4 is around here. That's going to be 7 over 4 here, so we can see it is roughly 7 over 4. And on the y-axis, minus 129 over 8. Minus 129 over 8 here. And that is just under the minus 16 here. So we can see here that we are correct. Okay, so we have our minimum point here. Next part says, explain why f must have two real roots. Well, we can see from the diagram that I've drawn here on GeoGebra here that it does have two real roots here. One at just over 4 and one here at just under minus 1. So let's just work those out. So let's just go back here again. It must have two real roots. So we know it has a minimum point anyway. So we know it looks like this. It has a minimum point, and that minimum point is not on the x-axis. It does look like this because it's a plus 2x squared. So therefore it's a U-shaped curve rather than an upside down. If it was minus 2x squared, it would look like that. So we know anyway that it has a minimum point down here at 7 over 4 and minus 129 over 8. Therefore it must hit the x-axis at two distinct points. So that's one way of looking at it. Also, you can look at it like this. If we take our function f of x, our function f of x here is 2x squared minus 7x minus 10. Now if we take the discriminant here, our discriminant here is going to be b squared minus 4ac. For that to have two real roots, that must be, our discriminant must be positive, must be greater than 0. So in this case, let's see, our a here is, our a, write it over here, a is 2, b is minus 7, and c is minus 10. So let's just stick it in here and see, do we get a positive value here? We should do anyway. So let's see, b squared. So b squared is going to be minus 7. It's going to be squared. Minus 4 times a here, which is 2. And then we've got c here, which is minus 10. We want that to be positive. Looks like it will be anyway. 7 minus 7 squared here is going to be 49. Here we've got a minus times a plus times a minus, so that's going to be plus in total. And then we've got 2 4s, 8, and 8 10s, 80. And that you can see, that's 129, which is positive, so therefore f must have two real roots. So therefore f must have two real roots. Okay, so that's part C1. Part C2 then is write the roots of f of x equal to 0 in this format here, where p and q are rational numbers again. Okay, so let's just write it out. The easiest way to do this, I think, there's a couple of ways of doing it, but we can look at maybe at the completed square format. It might be easier, so I'll do it that way. So let's take our completed square format was x 2 times x minus 7 over 4 squared minus 129 over 8. We want to let that equal to 0 and solve it to find our two roots here. So let's start. We'll bring this over to the other side, or add this to both sides, so that will give me 2 times x minus 7 over 4 squared is equal to 129 over 8. Let's divide by 2 now, so that will give me x minus 7 over 4 all squared, and that's equal to, we're dividing by 2 here, so that's just going to give me 129 over 16. Okay, next thing we've got to do here is let's square root here, so we're going to square root both sides. So here I'm going to get x minus 7 over 4 is equal to, now this has got to be plus or minus the square root of 129 over 16. Okay, almost there. So now let's just, remember we want it in this format here, so we want a number plus or minus the square root of another number here, and p and q have to be elements of q here. So what I end up with here is x is equal to 7 over 4 plus or minus the square root of 129 over 16. And really that's it. These are two rational numbers here, so that's fine. There are two roots. Now you could do this the other way as well. You could actually start with the original function 2x squared minus 7x minus 10 and use the quadratic formula minus b plus or minus square root of b squared minus 4ac over 2a and so on. You could do it that way either, but this is our result here. So that's it for question 1 anyway.